Here's the setup for the propagation of error problem that I would like you to try. After I give you the setup, take about 15 minutes to see if you can solve the problem all the way through on your own. If you get stuck, refer to the next 3 videos for hints on the strategy, finding the error in the original solution concentration M1, and finding the error in the diluted solution concentration M2. If you cruise all the way through to the end, or get there with a little struggle anyway, you can use the following 3 videos to check your thought process and check your work. If you have any questions, definitely reach out to me on Zoom because this is going to be a bit of a tricky one. So this problem will be similar to the previous propagation of error problem we did, involving the propagation of random error in the preparation of a solution by serial dilution. Here, though, we're going to have an added wrinkle where we refer back to the example we discussed in the review module on preparing solutions by serial dilution, where we prepare an aqueous ammonia solution by diluting 8.46 mils of a 28 weight percent solution to a final volume of 500 milliliters total. Here, though, we have an added wrinkle. We know, or we are now given, the random errors associated with each measurement. Both volumes, the original weight percent of the ammonia stock solution, and the density of the original ammonia stock solution. So note that these are random errors, and the error here will follow random error propagation rules. So we are told now that we dilute our ammonia stock solution, which had an ammonia concentration of 28 plus or minus 0.5 weight percent. We remove 8.46 milliliters of that solution, and that volume had an absolute error of plus or minus 0.04 milliliters. And we dilute that to a final volume of 500 plus or minus 0.2 mils. The density of the solution also has an error of 0.899 plus or minus 0.03 grams per mil. In our original calculation, we also used the molar mass of ammonia, and you can assume that the error in the molar mass of the ammonia is negligible compared to the measured volumes, densities, and concentrations here. So you can neglect the relative error in the molar mass of the ammonia. What makes this problem a little trickier than our previous example with serial dilution is to start our serial dilution problem, we had to convert the weight percent of the ammonia solution to a molarity of ammonia using the density of the solution. So error will propagate in that step as well, and this is your primary hint going into the problem, because both the weight percent of the solution and the density of that solution have error, which will contribute to the error in the original molar concentration of the ammonia. Your job is to find the absolute error in the molar concentration of the ammonia in the dilute solution. And if you didn't check out the review on serial dilution the first time, I'd recommend you go back to that first, or at least run the M1V1 calculation to determine what the concentration of the more dilute aqueous ammonia solution should be in molarity. Remember, if you get stuck, there's a complete solution breakdown in the next 3 videos. I'll see you there.